Okay. Now, look at this delta y by delta x formula. I'm going to write again in the next page. So for the function y is equal to x square, we got delta y by delta x is equal to 2x plus delta x. This is what we got. For small values of changes in x, a little bit of change in x. So small values of change in x means delta x is very small. When delta x becomes very small. Very small means how much small? There is no definite value for it. Okay, disproportionately small, you can say. Okay, if x is maybe in the order of millions, delta x is in the order of 1. If x is 1 million rupees, you can say delta x is 1 rupee. Okay, delta x becomes very small. Delta x becomes very small, mathematically expressed as, so this sentence that we have just written here, this phrasing that we have written here, mathematically we put it as delta x approaches 0. Delta x tends to 0. Delta x approaches 0. Delta x tending to 0 or delta x approaching to 0 does not mean delta x is equal to 0. It only means delta x becomes very small. When delta x becomes very small, delta x is negligibly small when compared to 2x. Adding delta x doesn't make any difference. So as delta x becomes smaller and smaller, delta y by delta x becomes closer and closer to 2x. Okay, that's what I meant to say here. As delta x tends to 0, delta y by delta x is going closer to 2x. Delta y by delta x is approaching 2x. Delta y by delta x approaches or tends towards 2x. Okay, so we can express it as delta x tends to 0, delta y by delta x tends to 2x. This is how we can write it. Mathematically, we write the same sentence as the following. Okay, I'll write it in English first. In the limit delta x tends to 0. In the case of delta x has no choice but to become smaller and smaller. In the limit delta x tends to 0, delta y by delta x tends to 2x. This is how we write it. Putting it mathematically, limit delta x tends to 0, delta y by delta x is equal to 2x. That's what it simply means. Okay, this is how we write it mathematically. In the limit delta x tends to 0, delta y by delta x approaches 2x. That's what it means. Okay, let us look at an example with some numbers for x. I'll take, say, x is equal to 4. Take x is equal to 4. And take delta x is equal to 0.1. Small change in x, but not very small, but not too small, to call it delta x tends to 0. Take x is equal to 4 and delta x is equal to 0.1 and substitute them here. You will get delta y by delta x is equal to 2 into 4 plus 0.1. You are getting 8.1. Now make the interval smaller. Now take x is equal to 4 again. Take x is equal to 4 again. But delta x, make it smaller than 10 times smaller than the previous case. So here, when delta x becomes smaller, find out delta y by delta x. Substitute them here. You will get 8.01. Make delta x even more smaller. Let's say now delta x is equal to 0.001. Now you will get delta y by delta x is equal to 8.001. So keep decreasing delta x, keep decreasing the interval. When you keep decreasing the interval, delta x is approaching 0. That's what we would say. As delta x approaches 0, you can see that delta y by delta x is coming, closer to 8. 8 means 2x, 2 into 4. So here, at x is equal to 4 or around x is equal to 4, when you take a small interval, this is on the right side of 4 on the number line. Take left side number. In other words, take delta x negative. If you decrease the value of x, if delta x decreases by a small amount, minus 0.001, you will get delta y by delta x close to 8 again, 8 minus 0.001. So here we can say that as delta x becomes smaller and smaller, as delta x approaches 0, delta y by delta x approaches 8. At x is equal to 4 or around a small interval, in a small interval around x is equal to 4, we can say delta y by delta x approaches 8. Similarly, in a small interval around x is equal to 4.1, it is 2 into 4.1. Similarly, in a small interval around x is equal to 4.5, it is 2 into 4.5. It approaches 2 into 4.5. Okay, so for every value of x, when the interval becomes smaller and smaller, when delta x becomes smaller and smaller, delta y by delta x approaches 2x. That's what this equation means. This equation means in the limit delta x tends to 0, delta y by delta x approaches, delta y by delta x tends towards 2x. That's what it means. We can also write that equation as the following. Limit delta x tends to 0, delta y by delta x is also called dy by dx. Dy means what? A little bit of change in y. Dx is a little bit of change in x. D is not a variable. D is just a symbol. Don't cancel D in the numerator and in the denominator. Don't do that. So dy is a small change in x, a small change in y. Dx is a small change in x. So this is dy by dx at a given value of x, at a particular value of x. It is also called derivative of y with respect to x. mathematicians call it derivative of y with respect to x. We call it rate of change in y with respect to x at a given value of x. At a given value of x means in a small interval constructed around the value of x. In a small interval constructed around x, as that interval tends to 0, okay, this tends to dy by dx. Okay, in the function, in the y is equal to x square, we have seen in the previous page. In function y is equal to x square, as delta x becomes smaller and smaller around x is equal to 4, delta y by delta x approaches 8. So in this example, derivative of y with respect to x is equal to 8 at x is equal to 4. Or in other words, this is rate of change in y with respect to x in a small interval constructed around x is equal to 4. Rate of change in y with respect to x approaches the number 8 as the interval becomes smaller and smaller. In other words, we can say at x is equal to 4, the rate of change in y with respect to x is equal to 8 in this function. So in this function, we can write in the function y is equal to x square dy by dx. dy by dx is equal to 2x. A small change in y by small change in x, or rate of change in y with respect to x at a particular value of x, at a given value of x, or derivative of y with respect to x is equal to 2x. What it means is, as delta x tends to 0, delta y by delta x tends to 2x. That's what it means. dy by dx is equal to 2x. At x is equal to 4, dy by dx is equal to 8. At x is equal to 4, dy by dx is equal to 8. It means at x is equal to 4, the rate of change in y with respect to x is equal to 8. So what do we mean by the rate of change in y with respect to x? At x is equal to 4, it means if you construct a small interval around x is equal to 4, in that small interval around x is equal to 4, as delta x approaches 0, delta y by delta x approaches number 8. That's what it means. So we say the rate of change in y with respect to x is equal to 8 at x is equal to 4. We also say this is rate of change in y with respect to x at a given value of x. In this case, the given value of x is 4. Or we call this rate of change in y with respect to x at an instantaneous value of x. In other words, this is dy by dx is instantaneous. dy by dx is instantaneous rate of change in y with respect to x. That's what it means. Instantaneous means at a particular instant. Generally, instantaneous is used in the case of time, but I am using it here because we are finding the change in y by change in x. We are finding rate of change in y with respect to x at a particular value of x. Here instantaneous does not mean in the given range of values of x. We are not taking any range of values of x here. We are taking a particular value of x. That is x is equal to 4 or x is equal to 5 or x is equal to any value that you like. So since we are finding the rate of change in y with respect to x, not in an interval, we are finding the rate of change in y with respect to x at a particular value of x. I would like to call it instantaneous rate of change in y with respect to x. Okay, instantaneous means at a particular value of x. That's what instantaneous means. So like this, we can take many functions and do it. Okay, I'll take y is equal to x cube and I'll find out dy by dx. Dy by dx means the rate of change in y with respect to x at a particular value of x. At a particular value of x, how do you find out? Take a particular value of x, construct a small interval around that particular value of x. In that small interval, make that interval as much small as possible. As that interval tends to 0, rate of change in y with respect to x tends to a particular value. That particular value is called dy by dx. Let us take this, for example. Y is equal to x cube. If x changes by delta x, let us say then y changes by delta y. So then in that case, y plus delta y is equal to x plus delta x whole cube. Expand this. Y plus delta y. If you remember a cube plus b cube formula, then you can use it. Sorry, a plus b whole cube formula, if you remember, you can use it. Or else, I don't remember. So what I'm going to do is x plus delta x whole square into x plus delta x. I'll write it like this. Then I'll do the multiplication inside. I'll expand this term. Multiply this, you'll get x cube plus 2x square delta x plus x into delta x whole square. Next, multiply dx, x square delta x plus 2x delta x whole square plus delta x whole cube. Now simplify this. X cube plus 3x square delta x plus 3x delta x whole square plus delta x whole cube. X delta x square plus 2x delta x square, 3x delta x whole square plus delta x whole cube. This is y plus delta y equal to y and x cube get cancelled. Y and x cube get cancelled. If you take delta x common, delta x out in the right hand side term, you'll get delta y is equal to delta x times 3x square plus 3x delta x plus delta x whole square, or delta y by delta x is equal to, we are getting 3x square plus 3x delta x plus delta x whole square. This is what we are interested in. We are always interested in rate of change in y with respect to x in an interval of x. Now look at this. As delta x tends to 0, that means as delta x becomes smaller and smaller around a given value of x, if you make the interval small, very close to 0. So delta x whole square, delta x itself is close to 0. That's what we are saying. For example, take x is equal to 1000 and delta x is equal to 1. Delta x of course does not tend to 0, but delta x is very small, of course. Not too small to call it close to 0. Okay. But anyway, take x is equal to 1000 and delta x is equal to 1. Calculate these values. Here if x is equal to 1000, this becomes, x square becomes 1 million. So this term becomes 3 million. And look at this term. This term becomes 3000. This term becomes only 1. If x is equal to 1000, this is 3 million and this is 3000, this is 1. If you make delta x even more smaller, so this becomes even more smaller, this becomes even further smaller. So what I am trying to say is, as delta x becomes smaller and smaller, as delta x approaches 0, these two terms are negligibly small compared to 3x square. Okay, these two terms are approaching zeros also. As delta x approaches 0, 3x into delta x is becoming smaller, delta x whole square is also becoming smaller compared to 3x square. So then we can say delta y by delta x approaches which value? 3x square. So here I can say that as delta x approaches 0, as delta x becomes smaller and smaller, delta y by delta x approaches 3x square. In other words, in the limit delta x tends to 0, delta y by delta x tends to 3x square. We can also write this as derivative of y with respect to x is equal to 3x square. That's how we can write it. So rate of change in y with respect to x is equal to 3x square. Rate of change in y with respect to x at a given value of x is equal to 3x square. At x is equal to 2. What are we getting? dy by dx is equal to 3 into 2 square, which is 12. At x is equal to 2, dy by dx is equal to 12. What it means is, if you construct a very small interval around x is equal to 2, as that interval becomes smaller and smaller, rate of change in y with respect to x in that small interval approaches number 12. So as the interval becomes smaller, rate of change in y with respect to x becomes closer to 12. That's what it means. So this is rate of change in y with respect to x in a very small interval constructed around x is equal to 2. Or we would say this is rate of change in y with respect to x at x is equal to 2. So dy by dx is equal to 12 means rate of change in y with respect to x is equal to 12 at x is equal to 2. That's what it simply means. So like this we can find dy by dx for some functions. Not only algebraic functions, we can also find dy by dx for other functions as well. Okay. Here, let's discuss few more. Take y is equal to x power 4 and try this. if you take y is equal to x power 4, y plus delta y is equal to x plus delta x whole power 4. You can write it as x plus delta x whole square into x plus delta x whole square. Expand and multiply, neglect the terms of delta x and simplify. If you do that, you will get y plus or delta y is equal to 4x cube. That's what you will get. If y is equal to x power n, then how do we generalize this? How do we write a general formula? For y is equal to x cube, y is equal to x power 4, x power 5, or root x, x power half, x power minus half, x power minus 1. So for whatever the value of, so when y is equal to x power n, how do we write it? We use binomial expansion here. We can write y plus delta y is equal to x plus delta x whole power n. Y plus delta y is equal to x to the power of n into 1 plus delta x by x whole power n. 1 plus delta, I took x to the power of n common. When x power n when x comes out, you will have 1 in the left term and x in the denominator of the right hand side, right term. Okay. Now we have something called binomial expansion. Binomial expansion is very simple. You know, a plus b whole square is equal to a square plus 2ab plus b square. This is how we expand a plus b whole square. Similarly, a plus b whole cube, we just multiplied it in the previous case. A cube plus 3a square b plus 3ab square plus b cube. Similarly, a plus b whole power 4. We can write a power 4 plus 4a cube b plus 3a square b and so on. So like this, we have a binomial expansion. Okay, for a plus b whole power n. For a plus b whole power n, this is a power n plus n into a power n minus 1. Well, we have binomial expansion here. A plus b whole power n is equal to a power n into a power n plus n into a power n minus 1 into b plus n into n minus 1 by 2 into a power n minus 2 into b square plus n into n minus 1 into n minus 2 divided by 1 into 2 into 3 into a power n minus 3 b cube into b cube and so on. This is the expression that you have. Okay, like this you will have terms up to b power n final. So we are going to make use of this binomial expansion. We can write, if a is equal to 1, and b is equal to some variable, let's say x, then this can be written as 1 plus x whole power n is equal to a power n 1 plus n into a power n minus 1, which is 1 power n minus 1, b is x here, nx, plus n into n minus 1 by 2 into this becomes x square. A power n minus 2 is 1, x square, and so on. Finally, you will have x to the power of n term. If x is very small, look at this binomial expansion. If x is much smaller than 1, when x is much smaller than 1, x square term becomes even more smaller. N into n minus 1 by 2 is just a number, but x square becomes even more smaller. I'll give you an example. Here, x is equal to 10 power minus 3. X square becomes 10 power minus 6. Next term is x cube. X cube becomes 10 power minus 12. 9, sorry. X cube becomes 10 power minus 9. So when compared to 1, 10 power minus 3 is 1000 times smaller. If 1 is divided into 1000 parts, each part is equal to x. If 1 is 1000 rupees, 10 power minus 3 is 1 rupee. 1 rupee is again divided into 1000 equal parts. So 1 rupee itself is very small when compared to 1. Okay. So here x is 1000 times smaller than 1. X square is 1 million times smaller than 1. X square is 1 million times smaller than 1. X cube term, the next order term that you get in this expansion, is 1 billion times smaller than 1. Okay. Suppose if you take 1 million rupees here, x is equal to 1000 rupees. X square is equal to 1 rupee. X cube is equal to 0.1 paise. If you talk it in terms of money, you will understand. Here, if 1 is 1 million, x is 1000 rupees, x square is 1 rupee, x cube is 0.1 paise. Okay. So here, when you compare with 1 million rupees, you can neglect 1 rupee. You may not be able to neglect 1000 rupees. 1000 rupees is not negligibly small when compared to 1 million rupees. But here, when you don't have to add 1 rupee to 1 million, you don't have to add 0.1 paise to 1 million. Higher order terms, if you take x power 4, it is even more smaller, x power 5, even more smaller. So all these higher order terms are negligibly small when x is much less than 1. So when x is much less than 1, adding these higher order terms does not make any difference. Okay, as I told you, if 1 is 1 million rupees, then x is n into 1000 rupees. N into n minus 1 by 2 into 1 rupee. Next, n into n minus 1 into n minus 2 by 1 into 2 into 3 into 0.1 paise. So adding 1 rupee, 0.1 paise, 0.01 paise, etc. doesn't add any value to it. So we neglect these higher order terms. So when higher order terms are neglected, we can say that this is approximately equal to, for x much less than 1, when x is much less than 1, 1 plus x whole power n is approximately equal to 1 plus nx. This is one of the most important approximations in physics. When x is much less than 1, 1 plus x whole power n is approximately equal to 1 plus nx. This approximation we are going to use to find dy by dx here. To find dy by dx, we are going to use this expression, this approximation. Let's see how. Here, when delta x becomes much smaller than x, delta x by x, delta x divided by x becomes very small when compared to 1. I'll write down this equation in the next page and we'll proceed further. So we have y is equal to x power n, y plus delta y is equal to x plus delta x whole power n. I took x out, y plus delta y is equal to x power n into 1 plus delta x by x whole power n. When you take x out, here x comes in the denominator. Now, delta x, when delta x is much smaller than x, that means delta x tends to 0. When delta x is much smaller than x, delta x by x is much smaller than 1. Delta x by x is much smaller than 1. This is a term whose value is very small when compared to 1. If its value is very small when compared to 1, look at the approximation that we have written. When x is much smaller than 1, 1 plus x whole power n is approximately equal to what? 1 plus nx. Similarly, we are going to use this approximation here. Delta x by x is much smaller than 1, so I am going to use 1 plus delta x by x whole power n. I am going to use this approximation and write this as 1 plus n into delta x by x. 1 plus n into delta x by x. Here in place of x, we have delta x by x. Now substitute this here. If you substitute this here, what do you get? You will get y plus delta y is equal to x power n into 1 plus n into delta x by x. Take x power n inside, you will have y plus delta y is equal to x power n plus n into x power n into delta x by x. Okay, so y is equal to x power n. Y is equal to x power n. Okay, so since y is equal to x power n, they get cancelled here. You will get delta y by delta x is approximately equal to delta y by delta x approximately equal to n into x power n by x can be written as x power n minus 1. What have we done here? We took delta x to the left hand side. So delta y by delta x is approximately equal to n into x power n minus 1. So what do we understand? When delta x becomes very small, delta y by delta x is very close to n into x power n minus 1. So we can conclude here that as delta x approaches 0, as delta x tends to 0, we can write delta y by delta x tends to n into x power n minus 1. What it means is, in the limit delta x tends to 0, delta y by delta x is equal to n into approaches n into x power n minus 1. This is what we are calling as dy by dx. So dy by dx is equal to n into x power n minus 1. So for y is equal to x power n, if you take this function y is equal to x power n, dy by dx is equal to n into x power n minus 1. This is the basic formula of differentiation. derivative of y with respect to x. Or what do we call it? Rate of change in y with respect to x at a particular value of x. Let's apply this formula to the functions that we have already done differentiation. So what is the formula that we have? If y is equal to x to the power of n, dy by dx is equal to n into x power n minus 1. This is the formula we have. You know, we differentiated y is equal to x square. We wrote down the derivative of y is equal to x square. Dy by dx. What did we write? For y is equal to x square, we wrote down the derivative dy by dx is equal to 2x. This is what we got. Apply this formula, you will get the same thing. If you apply this formula, here what do we have in place of n2? X power n. This is x square or x power 2. We have 2 in place of 1. So dy by dx is equal to 2 into x power 2 minus 1 or 2x. This is dy by dx. We also did it for x cube. Y is equal to x cube. Apply this formula. You will get dy by dx is equal to 3 into x power 3 minus 1 n into x power n minus 1. So what do we have? 3x squared. Dy by dx is equal to 3x squared. Okay. Similarly, take y is equal to x power 4. Dy by dx is equal to 4x cube. 4 into x power 4 minus 1. Applying this formula. You can take any power of x. Y is equal to 1 by x. Take this function. 1 by x means x power minus 1. Find dy by dx. Minus 1 into x power minus 1 minus 1. N into x power n minus 1. N is minus 1 here. So when you simplify this, you will get minus 1 into x power minus 2, or this is minus 1 by x squared minus 1 by x squared. So like this, we can write derivative of all functions in this format. Y is equal to square root of x. Y is equal to square root of x means y is equal to x to the power of half. Okay, we have half in place of n. So dy by dx is equal to half into x to the power of half minus 1. Half into x to the power of half minus 1 is minus half. Okay, which can be written as 1 by 2 into x power half in the denominator. X power minus half is x power half in the denominator, which can be written as square root of x in the denominator. So dy by dx for y is equal to root x is 2 root x. Okay, like this we can apply this formula. This formula for all functions in this form. If y is a constant, if y is equal to constant, what it means is y is not changing. Y is not a variable. It's not a variable physical quantity, it's a constant physical quantity, or it's a some number. If y is a constant, change in y for any amount of change in x is always 0. Whether you take small change in y or large change in y, it is not changing. We are saying it is a constant. So dy is 0, it means dy by dx is also equal to 0. Dy means what? A small change in y. We are saying y is a constant. So a small change in y is a 0. Numerator is 0. Derivative of y with respect to x is equal to 0. Let's do one more. Y is equal to x. How do we do this? If y is equal to x, maybe you can apply that formula as well. Y is equal to x power 1. So dy by dx is equal to 1 into x power 1 minus 1. You know y is equal to x power n, dy by dx is n into x power n minus 1. So when you simplify this, you will get 1. But instead of applying that formula, if y is equal to x, change in y is also equal to change in x. You don't have to apply that formula. If y is equal to x, change in y is equal to change in x. A small change in y is equal to small change in x. It means, take dx to the left hand side. It means change in y and change in x are equal. So numerator and denominator are equal. So dy by dx is equal to what? 1. So if y is equal to x, dy by dx is equal to 1. Rate of change in y with respect to x is equal to 1.